again, from your favorite artist electronist here, Mr. Q12. I dismounted the circuit that I had before with the BD681, and I mounted back the voltage regulator there on this enormous heatsink here. So I tested that on this heatsink, and now this voltage regulator here. And I continue my list here. So here is the big radiator, this 190 with 190 with 6mm size is this one. And I got a couple of readings here, not that many. I'm keeping everything at 9 volts with a maximum of 0.94, almost 1 amp. Because maximum, because of this potentiometer is at its maximum here, cannot rotate further than that. And yeah, this is cooking. This is cooking quite well. It's very hot. Well, I'm not sure. I'm not completely sure, but it is hot. I'm not sure how many degrees it has, but it is a bit hot. It is the maximum for this 1 ohm resistor that I'm having here, which apparently it is doing well. Is doing fine. There I am having that transistor, big transistor, that is switching this big transistor here. This guy, 2N3773, is underneath there. And I rewired everything. This is the reading, so 9 volts. I modified slightly this list that I'm having here. There, I was having originally the voltage regulator wattage that I was calculate it wrongfully, so I stopped after that. After I introduced this 1 ohm this resistor, 1 ohm resistor, when I'm getting the amperage with the voltmeter over its ends, and that's what I was doing here, and I was calculating that times, so the amperage in the circuit times VIVO, which is voltage over V in, V out of the regulators. Right now is VIVO. Right now I'm collecting the voltage over the V in and V out as it is set up like this. And to get only the V out voltage, I must take this probe and put it there on the negative, because this is connected already to the V out. So V out to negative, and I'm getting this V out voltage here. So my power supply. So this is VIVO voltage over the regulator here, but this is power supply voltage here. This power supply amperage and power supply wattage. This is what I changed from before, and I'm calculating in the same time I'm calculating the wattage as well. Those numbers they are erroneous. So yeah, I cut them because they are from previous data calculations, and they are erroneous, these ones. But this here are actually power supply wattage. What I did, I multiplied power supply amperage times power supply voltage, and I'm getting power supply wattage. Here is the temperature, and now I'm looking there because I was filming and running everything. 35 right now. Less than 5 minutes was 32, but now it's 35. Okay, so I'm having 35 degrees in 5 minutes. A bit over 5 minutes actually, as it is right now. And I'm collecting the voltage over this 1 ohm resistor, which is this, from this to that side, with this other multimeter that I'm having separately, and I'm collecting the data. And this is actually, I'm measuring with the voltage, as you can see. I'm putting it on the voltage here range, but I'm actually obtaining the amperage, because it's 1 ohm and voltage equal amperage. In this particular case it is the same, 1 volt equal 1 amp, and what I'm getting here is 1:1 ratio. And voltage regulator, like I said, is VIVO times current over this 1 ohm resistor, which is in the circuit. Let me show you again. Over this voltage regulator, from here to here, I'm collecting the voltage from its input and its output. And this power resistor, which is 1 ohm, and this is uncoupled here. This is no more right now, and I leave only this 1 resistor ohm. As you can see, that 5.6 guy is there, is not used anymore. And this is more correct like this. Let me check the temperature. Yeah, it's warm. It's comfortably warm right now, and is the entire plate comfortably warm, but not. Let me check this. Oh. This is very hot, very, very hot. It's on the limit. This resistor and that resistor that I had it before, they should be mounted on their own heatsink. I must have a heatsink for this transistor, for the voltage regulator when I'm testing it, and for the resistor. So yeah, right now I'm having I'm having for this for this one, and for this one I'm having large heatsinks, but I'm starting to realize that I will need a heatsink for the resistor itself. I was aware of this, I was expecting this, but I thought I will work it gradually, and I will probably not need it, because I will step up little by little. Let me check here the temperature. This is slight warm. It's not hot at all. This is the most hot element, this resistor here, and this is excellent. 36 degrees is fantastic. Well, it was 35, now it's 36. Yeah, right now it's 10 minutes of filming that I'm looking on the display right now, and I should note this 36.7 in a little bit more than 10 minutes. So I changed that while I'm filming here, and that's it. This is the wattage. Like I said, VIVO is this VIVO 5.48. You can see it here actually, because it is measuring right now. This VIVO 5.48. It was, for some reason it changed a little bit to 49, and this 1 ohm 0.89. These two values I'm multiplying, and I'm getting the wattage across voltage regulator, which is right now is almost 5 watts, 4.8, which is Yeah, fantastic. It is answering my questions very well, actually. I'm very happy, very happy at this point with this setup that I'm having here. I'm more than happy because I'm realizing what it takes, how much material, how thick and how large the heatsinks should be. And that's what all this experimentation that I'm doing here, this is what is answering to me. Look, 37 right now. Yeah, it's increasing with time, but I think it will stabilize at some point. I really hope. But right now I'm in the ballpark, and if I'm changing that with even less, with this one, with 0.2 ohms, as you can see, you can read it here at 50 watts. I'm not completely sure how resistant the transistor will be. I think it will overheat it. But for what I can see so far, all the heat is concentrated only on this tested component that I'm having here. So right now at 5 watts, I am very pleased. I can even heighten it a little bit more than this. I'm not sure if I will actually do it because I already got my answers so far. So you need a very big heatsink for these three variables in this circuit: the transistor, so this power transistor, this voltage regulator that we are testing it, and the resistor. They all must have heatsinks. All three. You have to calibrate them. You have to test them into a setup like this. And after you get the test, in the same time, I'm starting to realize what I'm actually doing here with all the setup that I'm having here. I'm actually not only testing the components themselves. Of course, I am testing them as well. In the same time, I am testing the heatsinks, how large they should be, how thick they should be, the area of the heatsink, the thickness, and they are working hand by hand. So I'm actually testing 4 things: these 3 components and the heatsinks over them. Actually 6 components, because in this case what I'm having here, actually I'm testing 5 components: these 3 components, this heatsink and this heatsink. But I should put a heatsink here. So the sizes of these heatsinks, they are tested indirectly in the same time. Well, it's actually quite directly right now. It's quite directly, but you don't think of it too much. You think how to equilibrate, to balance everything, not to be the temperature, the size of everything, and the power of everything. So right now I don't have any target in my mind. I don't really want a certain power or a certain size or a certain heat dissipation temperature, because I'm testing. I'm playing right now. This is child play what I'm doing here. I'm very pleased, and I believe I got my answer with all this time put into the circuit. I believe it's raining outside. Very nice weather. I like it. It's a spring right now, and it's a very calm raining. You can barely see it's raining. Yeah. Okay. So I'm also kind of stressing my power supply. I really learned a lot with this circuit. So increasing the voltage will decrease the amperage, but will maintain the same wattage, or increase it even, whatever. But it's better to have a higher voltage than I'm having it right now. Even 12 volts and probably 20 volts, it should be quite good. The higher the voltage, the better, pretty much. But it is dependent on the power supply. That's the idea. This power supply is better if you consume more voltage from it than the amperage. So amperage, keep it low, voltage high, make it high. But there are other power supplies that you can use the inverse of this. More amperage from them and lower voltage. So because they have a thicker copper wire winding in their transformers, stuff like that, or they are working on totally other principle than this one. But this priority is higher voltage, lower amperage, and you will get the wattage that you need in these parameters, not stressing too much the components that are inside it. It really rises to 38, but now I'm at 20 minutes. I'm very pleased. This didn't change, which is good. Yeah, I'm really pleased. It's a bit tricky how to work with this circuitry that I'm having, this testing, loading test. But after using it for a bit, 1 or 2 weeks, I don't even remember, because I took it very slow. I took it very slow and very extremely gradually like that. So I don't remember the time I put into all the testing that I did. And I did test a shit ton of stuff with this. So how are you? Yeah, it's kind of, yeah, it's burning my skin after a couple of seconds. Yep. It is, but it's not instantaneously. That's the probe for that. So 38. I should test it probably. I don't have a secondary. Well, I'll have to sacrifice this and get the temperature here. Yeah, 60-ish, around 60 right now. Yeah, it's hot, but in some good parameters is hot. I should definitely change this resistor with a higher wattage. I actually have a 10 watt. These guys. Well, I should take one from this. So it remained like this from my earlier experiments. So 10 watts, 1 ohm, and I should change that with one of this, and like that. The next step is to actually make something practical. I have absolutely nothing in mind. My only focus, my only concentration was to actually test everything, and I did it, and I'm super happy. So mission accomplished. Yeah, do you hear the rain outside? It's starting to rain very heavily right now. and a very good, nice breeze. A little bit of cold air is coming from outside. All right. I was concentrated only on this subject to get as much power on what it takes, how much material it takes for the radiators, and yeah, for sure I learned a lot of stuff. And let me close the experiment because I keep it long enough, so it is proving my point. It proved its point. Okay, next step after this is to make probably a box for this and put actually all my my testing resistors and components that I test them, even that LM317, because later in life probably I will look back to these movies to remind me what the hell did I do here, and and having all this like a kit, you know, in a single box, minus this heatsink. Probably I will not include this large heatsink, but that heatsink, yeah, is fine to include, to leave it there. The next step after this thing is to actually make something practical with a voltage regulator, with a heatsink big enough for the voltage regulator, with a targeted wattage for the voltage regulator, with a targeted input voltage here, like this 9 volts that I'm using right now, or even less, because it is kind of doing the job. A little bit erroneous as the voltage is decreasing, especially at 5 volts there or here, but it is a little bit erroneous. Listen, the rain outside, very cool, very, very cool. Let me show you the rain. Actually, it's raining outside. You cannot probably see the rain itself, but you can hear it. Yeah, you can see something. Yeah, very cool, very, very cool. I like it. Right. So this is summarizing everything. I'm not completely sure if I will actually do something. This is the strategy here. If I will ever need to either test another component instead of the voltage regulator, another transistor probably, maybe, through all this thing, to test its maximum wattage and the radiator that it needs to have for a targeted wattage, for a targeted voltage supply, first I will have to do this arrangement, this testing that I'm having here, which is looking very weird as it is here right now, and a bit hard to comprehend only from looking. But when you do it, is a couple of wire and a little bit of attention, and of course very good circuit diagrams and pinout to actually see exactly what you are doing and where everything is. And after that, after checking and testing the shit out of that component, you will know for sure what size of radiator it needs, at what wattage you can push it up, and how much temperature you will get out of it, dissipation, and then include it into a practical circuitry that you can use and not be afraid it will burst in fire because you miscalculated something. That's the idea of this entire experimentation that I did here, and I'm super pleased and super happy with what I'm getting here, what I got so far, and the level I reach with doing all these things. I really like it. And again, I'm thanking all my friends, especially the American friend. The English friends were very quiet. They kind of mumbled here and there a little bit, but something, but no, not that much. But I thank them anyway. So yes, this is it. Thank you very much for watching. Thank you very much for staying close to me, watching and understanding all of this and what it needs to function properly. And thank you for watching my movies and for leaving a like there after you finish the movie. Yeah, thank you very much. Arrivederci, sayonara, auf Wiedersehen, la rivedere. From your favorite artist electronist, Mr. Q12 here from Romania. Bye bye.